Let's begin. This is likely your first set of physics notes, and it's probably the first real new concept we're going to see this year. Okay, so hopefully your brain is ready to roll, you're adequately caffeinated or hydrated or whatever you need to be, and you're ready to roll here. You've probably done scale drawings at some point before, right? Maybe in like grade 7 shop class or something like that. You do scale drawings?
Yeah.
I get a little bit. That's what you did? Really?
Yeah, we didn't know.
Okay. So today, you're going to know what a vector is. We're going to understand vector direction conventions. There's actually 3 of them, so it's kind of like that bilingual thing. You got to be able to speak different conventions and be able to draw a scale drawing of a vector. In the very near future, we're going to be adding and subtracting. So before we can do that, we need to draw vectors. That is a vector. What does it look like? Looks like an arrow, right? And math, they call that a ray, I think, right? Because it has an endpoint and a thing at the end. But that's basically what a vector is. It's an arrow. Okay? So, I think you've got to define it right there, right? A vector is simply an arrow that represents a vector quantity.
Do we have to write the rest of that down?
If you want to have it, you should know it, Carter. Whether you write it or not is entirely up to you. If writing it helps you, so that you can remember it, or writing it so that you can check it out later helps you, then that's fine. If you choose not to, whatever. I'm not the notes police. You can do that too. I'm going to post these to Schoology. If you think you'll do better just sitting back and listening, you do that too. Whatever works for you, man.
Is it kind of already half written on here?
Yeah. So a vector is simply an arrow that represents a vector quantity, and the length of the arrow represents the magnitude or size. I'm just going to wait there because I can see people writing, and I know not to talk while people are writing. The word magnitude always causes me grief because 4 days from now, or maybe later when we get to the test, people don't know what the word magnitude means. The word magnitude just means the size. How big the vector is. Is it 20 kilometers an hour? Is it 47 newtons? It's the number part. How big it is. That's the magnitude. Okay, so the length of the arrow represents the magnitude of size of the vector. In other words, the longer the arrow, the bigger the number. You've got a vector that's 50 kilometers an hour and another one that's 100. Well, the one that's 100 is going to be twice as long. Okay, it's a scale drawing, scale representation of this vector quantity. And the direction that the arrow points represents the direction of the vector quantity. That particular arrow is pointing to the right. Okay, and the direction is important as well. What are these vector quantities that you speak of? Well, vector quantities are quantities that have a direction associated with them. It's the direction that makes something a vector. If there's a direction associated with it, that's what makes it a vector. I'm going to give you a list of examples right away. Actually, it looks like you have the examples already. Have you got examples there, Matt? Yeah? What are the examples that I gave you? No, the one. Don't you have it right on your page? Examples are? Common examples?
Velocity, acceleration.
There you go. Those are the big 4. Fantastic 4 vectors. Displacement, velocity, acceleration, and force. What does displacement mean? Catherine? What does displacement mean? When something's displaced. Now, if it's displaced, when something is displaced, it means that it's moved, and because it's a vector, it has to be moved in some direction. Right? Like 10 steps west, 47 meters south. Velocity, how fast you're going in a direction. Driving down the highway at 100 kilometers an hour east. Acceleration, meters per second. When you drop something, it accelerates the Earth at 9.8 meters per second squared down. Force. Okay, newtons in a direction. The opposite of a vector is what's called a scalar. Scalars are quantities that do not have a direction associated with them. No direction. Things like mass, Time. How much do you weigh? 47 kilos. South. Doesn't make sense. How long did it take you to run the mile? 12 meters east, or 12 minutes east. Doesn't make sense, right? If there's no direction, it's a scalar. Okay, the classic question whenever you're given a new concept like this is, why do we have coordinates, right? Okay. So where would you use, not you, where would someone, some job, what kind of job might use a velocity vector, do you think? Besides a physicist. That's usually the first answer. Okay? The guy that's helping the pilot fly the plane, the navigator. Okay? They obviously have computers that help them, but they need to know what they're doing backup. They may need to plot a course using vectors, using the wind speed, right? If you're the captain of a boat, you need to understand currents and vectors that way, right? Force, absolutely. Engineers, when they're building bridges and stuff, okay? And of course, good old rocket scientists. Oh, you know what this means?
No.
You don't? Okay, so 309. Back to our question here. So I told you what a vector is. I told you what a scalar is. Now I'm going to see if you know. I can apply that knowledge. So I hope you're paying attention. Which of the following properties from physics do you think is a vector? Speed, density, momentum, or volume? What's the definition of a vector? It needs to have a direction. I will start the question. I haven't started the question yet. Now you can answer. Question 1. Which one of those do you think is a vector?
I don't know. I give up.
Just going to point out too that it's not going to be good enough to just cram for the test in here. You're going to have to pay attention as we go along.
What's momentum?
Momentum. That's when your mom really gets on a roll, eh? Woo! You might not know what some of those things are now. Make sure you press enter. Correct answer is C. Momentum. Because when Leighton tackles someone from the other team, right, he has to stop that guy's momentum. He's got that with your head, yeah. Right? Momentum is the vector one. This one might be a little bit harder, but I've given you a clue already today if you were listening carefully. I can't say that I did it on purpose, but I did it accidentally. Man. Which of these do you think is a scalar? What's the definition of a scalar? Correct answer. No direction. Not even one. Yeah, this is a bit more of a guess. But there's none of it also. Which one is a scalar? You've had a couple clues to this one already in the last few days. Which one do you think is a scalar? Okay, the Jeopardy song is almost done. Enter your final answer, please. Come on, Carter. Correct answer is B. Not bad. Remember, density is in grams per cubic centimeter. The density of the ethanol wouldn't be like 47 grams per cubic centimeter southeast. Does this make sense? Gravitational field strength, what did I say? Gravity, 9.8 meters per second squared.
Yeah.
I set it down. I just said it a few minutes ago. Down as a direction. Magnetic field strength towards, from north to south. You might not know that. Torque has to do with like rotational, right? In a direction. Not an easy question. That's okay. Okay, back to the learning part here. Okay. You don't like the learning part. What we're doing here is we're sort of laying the groundwork, right? Like this is the boring stuff. I'm not going to test you on this, but you got to know it before you can do the real stuff, right? Okay. So vectors are represented algebraically when you're writing it or when you see it in a textbook. Represented algebraically by a variable, a letter, with an arrow over it like this one for velocity. That little b with the arrow we would call a vector. You gotta listen, guys. You really do. Okay. Okay. Quite often, they're italicized or they're bolded to make them stand out in books, especially if they're really old textbooks before they had sort of computers and they couldn't put that little arrow over top. When you're handwriting them, most people just put a V and then they draw the arrowhead kind of like that. They don't bother with the other half. If you want to do yours like this, you go right ahead. Yeah, that's really poor, isn't it? That's why we just do it like this, right? Generally, you use the letter, like V for velocity, F for force, that kind of thing, right? When representing a vector graphically, in other words, drawing it, you can move the vector anywhere you like, as long as the length and the direction which it points remain the same. Those are the two things that are key. The length and the direction must be the same. For example, the two vectors shown below are considered equal, even though they do not have the same starting points. Now, you might think this is intuitive, that no one's going to make that mistake, but I've had students in the past that didn't realize you could move it around. Okay? Those two vectors are equivalent. How come? Because they're the same length, and they point in the same direction. They are the same. It's the same thing as me doing this. Are those equivalent?
No.
Yes. They both represent the same thing, 2 of whatever. We know what 2 means. One's in blue, one's in red. One's written with the loopy thing, the other one's not, but they mean the same thing. They mean 2. Okay, and they're in different spots on this page too. No, you just have to know it, Carter. I am not the notes police. I will not be checking your notes. Your notes are for your use only. You do what you need to do. Now, here's another key point that kids quite often get confused about. The unit of magnitude, right? The unit is what comes after the number, right? Like 5 meters per second or 27 newtons, right? That's the unit. The unit of the magnitude of vector depends on the type of vector you're representing. There is no unit for vectors. Vectors are a category of quantities. For example, a displacement vector would be measured in meters. Velocity would be meters per second. Force vector, newtons, and so on. Okay? Okay. Now we need to talk about direction. Okay? What are the naming conventions? How do we describe direction? I'll start with the easiest and we'll work our way to the hardest. Direction of a vector can be measured more than one way. Here's an easy example. A man is following a scavenger hunt. It's a terrible scavenger hunt. He used to walk plus 35 meters and then minus 10 meters. In other words, 35 steps to the plus, which would be generally, or forward to the right, maybe you might say, and then 10 steps back. Not really much of a scavenger hunt, I don't think. Oh, that's not good. Yeah. Okay, so all that means is he would go plus 35 and then back 10, right? That's all that is. So positive and negative is one way to describe direction. And it's very simple, it's very basic, but we actually use it quite a bit. Okay? We define it in the question. We'll say a certain direction is positive, and the reverse of that is negative. And most people just get that intuitively. I'm not too worried about that. Okay? That's the easiest one that you already know. Here are the harder ones. Do you have that written down? Good. Because what really matters here is the direction. Okay? Watch really close. An airplane is traveling at 200 kilometers an hour at 40 degrees south of east. Let's just ignore this one right here for the time being. Okay? 40 degrees south of east. How much space do you have there, Tyler? Quite a bit? Yeah. Excellent. Okay, so what I want you to do is draw a reference like this. And we're going to label that north, east, south, west. Okay? Believe it or not, people lose marks because they can't remember which way east is. Yes, thank you, Carter. It's to the east.
You know how I remember? My mom used to.
Oh, yeah? Okay. If you might think you might make that mistake, put that reference on your cheat sheet. 40 degrees south of east. So we look to the east. Watch, you guys. This is the important part. We look to the east, and we're going towards south. Okay, so I'm going to just draw a line on here. Let's make it like this. Okay, so there it is there, right? So I'm looking east, and I go south of east. I go towards south, south of east. How far do I go? 40 degrees. 40 degrees south of east. You gotta look east first. Of east. Okay? If you have a protractor, you can use it. I haven't quite gotten that yet, but go ahead. Somebody might need a refresher on how to use a protractor. 40 degrees south of east. Okay? Now, the other way to say it is east, 40 south. I find over my years of experience, students prefer this method because it's in order. I look east, and I go 40 degrees towards the south. I don't like it because I don't know. I grew up with this one. This is the way I was taught. I'm multilingual though. East, 40 south. So look east, go 40 degrees towards south. Does that make sense? Yeah. Give me the nod. I want to make sure that people, yeah? 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 Guess what happens after I show you something?
Whoa.
So hopefully you weren't nodding. Oh yeah, I know. I know what he's talking about. So which of these arrows shows the direction 30 degrees north of east? Or east 30 north? Is it A or is it B? Yeah. Yeah. No, it's the recording the screen. Then it gets posted to YouTube. Okay. Here's the last naming convention. This is the one that the pilots actually use. Okay? When you were sitting in the cockpit of the plane, you would hear the aircraft controllers giving them bearings, giving them directions to fly. Okay? And the way this works is, can be boats, doesn't have to be planes. Sailboat is moving at a bearing of 210. I put the bearings in square brackets. I think that's just a convention that I use. I don't think it's anywhere else. This method assumes that 0, 0, 0 is north and revolves clockwise. Draw this picture. I'll get you in a second, Joel. Put 0 there, and we're going clockwise. So east would be 90. South would be 180. West would be 270, and then north again is either 360 or 0. That's what pilots actually use. Okay? In fact, the runways are named when they talk about what runway the pilot's going to land on. The runway is named by, if it's pointing in this direction right there, if that's the runway, they would call it runway 20 because it's at a bearing of 200. Okay, all the runways are named by the first 2 digits in the bearing. Joel, you had a question? No? Okay. Now, some of you may have learned already. I'm guessing, I don't think there's too many people that have taken grade 12 math yet here.
I did.
Did you? Or like pre-calc. In math, they like to do this. They start 0 there at east, and then they go 90, 180, and they go 270 this way. They do it to be wrong. In math, there's reasons for it, okay? They also, anyone ever heard of the unit circle yet? Maybe? Okay, this is an offshoot of the unit circle. Nothing to do with real life. Okay? This is what, on the left-hand side, pilots use. You will occasionally see it in textbooks. It's wrong. This is what pilots use. 0 is north, 90 is east, 180 is south, 270 is west. Okay, so a bearing of 210, which direction would that be? So I'm going to draw, hopefully you guys have enough room. I'm going to draw my reference crosshairs again. Direction or bearing 210 would be? Which way?
33.
Who said that? Well done. It'd be like that, right? 180. What would this angle here be? It'd be 30 degrees, right? That's 180. So all the way to there would be bearing 210. The reason that's a little bit better is because it's quicker to say, if everyone sort of follows the same convention, east 40 south, you got to sort of stop and think about it, right? The numbers reset after 90. There's no reset here. It's a 0 to 260. Very convenient, very quick. Question goes. No? Oh. Hey, guess what's coming next? You're going to have to enter the answer here late right away. Clicker. Connor. Which vector is at a direction of 300? Bearing 300. A, B, C, or D? Yeah, huh? Yeah.
Pretty cool.
Yep.
Oh.
You start with 1 centimeter equals. Always, always, always. I'll be circling that on your tests when you make that mistake. Okay, it's part of proper communication. 1 centimeter equals. Okay, we're going east, right? So we're going to draw our line straight east, but how far do I go? I go 300 newtons, but 1 centimeter is 50. So 50, 100, 150, it's going to be 6 centimeters long. That is a scale drawing of a vector. Okay, 6 centimeters long. Yep. If you want rulers, they're up here. It doesn't have to be exactly 6 now. Like, we're not actually doing with them anything, but you will have to be able to draw a scale one, right? Oh, I was pretty close.
Do I put an arrow on it?
Yes. Oh, now while I think I may be in the next slide here, but
You have to put a dot on it too.
at the end, no. I can't make it 6 long. Okay, the 6 centimeters goes right to the tip of the arrow. The 6 centimeters goes right to the tip of the arrow. Okay? Now, how many people are so accurate that they're going to get exactly 6 centimeters? None of you, me included, okay? Here's the error that I will allow. Plus or minus 3 millimeters. You can be out by plus or minus 3 millimeters, which means this one here could be anywhere from 5.7 centimeters all the way to 6.3 centimeters. If you can't draw it within plus or minus 3 millimeters, you shouldn't be here. It's not that hard, okay? If you get it wrong, you're going to be more than that. I've never seen anyone be out by more than 1 or maybe even 2, okay? It just doesn't happen. Plus or minus 3 millimeters. What about the angle? what would be fair? Plus or minus 3 degrees, Martin. Okay, which is, it's quite a bit actually, right? If you take your time, it's very, very, very easy to fit inside that error. That's the amount of error that I'm going to allow. Okay, it's extremely fair. That's the same amount that they put on the provincial math exam. So that's where I got the number from. Okay, so here's what I want you to do. I want you to draw scale drawings of the following vectors. Okay? I'm going to give you like 10, maybe 15 minutes, and then I'm going to give you some answers. There's a ton of rulers here, and I have a whole load of protractors here as well. You just need to cut them out. Okay? I have 360-degree rulers, or protractors, and I have the old-fashioned half-width ones as well. Okay, I'll get you some scissors. First thing I'm going to do is I'm going to draw my reference west of north. Okay, so there's north. I'm going to the west of it, right? So I'm going over here somewhere. It has to be 30 degrees. So this angle here has to be 30 degrees, right? How long do you draw it? You must draw a scale. There's a mark for the scale. You must draw the scale. 1 centimeter equals 1 centimeter of length represents so many kilometers. I'm going to pick 5. Every centimeter represents 5 kilometers. How long does my arrow have to be then? 5 centimeters. Has to be 5 centimeters long, and it has to be 30 degrees to the west of north. I purposely thrown a whole bunch of curveballs at you here, because these are the things you're going to see, right? And it's okay if you see a curveball here, right? 45 newtons at 64 degrees above horizontal. Yeah, I haven't shown you that, above horizontal, right? That just means that horizontal means flat, 64 degrees. That's all it means. 64 degrees above flat. Is everyone good with A now? I want you to realize the difference between writing it this way and this way. 30 degrees west of north. Where do you start? You start at the end, west of north. But when it's written this way, north 12 east, you start there. Right? That's why I threw those together in there, right? So we did the first one. We went 30 degrees west of north. Right? So B here's B, north 12 east, so I'm going to draw my line north. Now here's a shortcut if you want. You don't have to draw all the crosshairs. You don't have to go like that. You could just draw what I call the reference line. You could just draw north, because that's the only one that really matters. So I've got north 12 east. I look north, and then I go 12 degrees to the east. That in there is 12 degrees. Okay? How far? 15 meters per second. So I'm going to have 1 centimeter equals. I talked to McKenna about a bit about this. There might be others that are not sure about the scale. 15 meters per second. You could go 1 centimeter. You could go 1 meter per second if you want. Then how long would your arrow have to be? 15. If you went 1 centimeter equals 3, well then it would be? It would be 5. You could go 1 centimeter equals 5, and then it would be 3. You could go 1 centimeter equals 10, then it would be 1.5. Some people like to just go 1 centimeter equals 15, and then everyone's only 1 centimeter long. It's pretty small, yes. Pick, in this case here, your best answer is probably 3 or 5. I'm going to say 1 centimeter equals 5 meters per second, and this is going to be how long? 3 centimeters long. Okay, are we good? It's still going to take some practice. 45 newtons at 64 degrees above horizontal. This one's another curveball. Above horizontal just means flat. So you're going to go 64 degrees. Could you have gone this way? Absolutely. It just says above horizontal. It doesn't say to the right or to the left. Unfortunately, there are some rules that are not hard and fast. 45 newtons, so I'm going to have something like 1 centimeter equals, what did you go? 10? 10 what? Newtons. Then it's going to be how long? 4.5 centimeters. Yeah? Good? Last one, D. 8 meters at 175. This is that bearing method. 175. This is 180 down here, so 175, I'm going to need a little tiny angle there of 5 degrees, right? Is that what you had? And it's 8 meters, so I would say something like 1 centimeter equals maybe 2 meters. And then how long would your arrow be? Be 4 centimeters long, right? And again, plus or minus 3 meters, or plus or minus 3 millimeters, plus or minus 3 degrees. Okay? Most of the time I can just look at it, yeah, that's right. Occasionally I have to get the ruler out. Okay? I strongly suggest pencil. How many people made a mistake already once today? Just about everyone. Get a pencil. The most important part of the pencil is this part, the eraser part. Use it. Okay? Alright. You can keep the program. If you cut something out, keep it, stick it in your binder. If you don't have a pocket, you can punch a hole in it, stick it in the ring, whatever. You can keep that one. I want the nice ones back. Oh, wait, no, I'm missing that. So wait, please. If you got a little bit of plastic garbage, throw it out. Oh, remember tomorrow, you guys, I'm not here, you guys are working on the lab.
What is that? Oh.
Tanner, you know what that means. They know you're first.
It probably is black.
Well, Dion can't draw that. Right there.
No, they give them to you.
Oh, no, these are air.
They give them to you.
Oh, I thought that was one from the bus.
They're cheap. That's part of the price. You pay plenty.
Put it away.
Here's, I'll sign you back in, see ya.
What? You have to, you know.
That makes sense.
Yeah.
No.
You weren't aware. You can't take care of it.
He's like, it'll be parked there, I will need you.
Yeah, that's it. Get your merit card. Either make your grab or class or the, I don't know, if you were in the beach yesterday. I thought we were gonna be outside for the stuff.
Anybody got garbage?
You have to be attention.
You put the glue on the wall. That would make Hey.
Wait, I'm just gonna put this on top of the product cabinet here, so we just like grab this off.
They give you so much room in the park at that little park.
Yeah?
And then I had my tiny little park because my grandparents vehicle was